Okay, so in this video, we're going to have a look at how to add and subtract surds. Adding and subtracting surds is very similar to adding and subtracting like terms in algebra. So before we even look at this, I want to look at some recap questions on how to add and subtract like terms. So we have 13a minus 18a. They are both like terms because they only have the only polynomials they have are a, and the powers are the same. Therefore, we're going to do 13 minus 18, which is minus 5. So we have minus 5a. 13a minus 18a is minus 5a. In question B, we have minus 19x squared plus 7y plus 18x squared. The only two like terms here are minus 19x squared and positive 18x squared. So we can only add and subtract those two terms. Minus 19x squared plus 18x squared. Well, minus 19 plus 18 is minus 1. So we have minus 1x squared. There's no need to put the 1 in front of the x squared. But what do we do with this plus 7y? We need to add it at the end. So our answer is minus x squared plus 7y. Okay, so remember you can only add and subtract like terms. When looking at adding and subtracting surds, it's exactly the same. So in question A, we have 5 root 2 plus 7 root 2 is equal to 12 root 2. So this, if we have a look here, they are like terms because they are both lots of root 2. 5 lots of root 2 plus 7 lots of root 2 is equal to 12 lots of root 2. Another way of looking at this is pretending this says 5x. Let x equal to root 2. 5x plus 7x is 12x. But instead of x, we're using root 2. With question B, we have 8 root 3 minus 19 root 3. They are like terms because they are both in terms of root 3. 8 lots of root 3 minus 19 lots of root 3. Well, 8 minus 19 is minus 11. So we have minus 11 lots of root 3. So another way of looking at it, algebraically, instead of writing root 3, we could write it as 8a minus 19a. And we know 8a minus 19a is minus 11a. It's just that instead of writing a, we're writing root 3. So let's have a look at some examples where we actually work them out. Simplify each of the following. 2 root 5 plus 6 root 5 is like saying 2x plus 6x, which is 8x. But instead of x, we are using root 5. So it's going to become 8 root 5. Question B, we have one lot of root 3. Root 3 minus 5 root 3. It's like saying y minus 5y. It's just that instead of y, we're using root 3. So y minus 5y is minus 4y. So root 3 minus 5 root 3 is minus 4 root 3. Question C. We have 3 root 7 minus root 6 plus 2 root 7. What are our like terms? Well, let's rewrite this as 3x minus y plus 2x. I wrote it as x for root 7. So because it said root 7 here, I had to use x. But because this was root 6, I had to use a different polynomial. So 3x plus 2x is 5x minus y. Except instead of using x, I'm using root 7. Instead of y, I'm using root 6. And that's it. Hopefully you'll be able to do this without substitution with x and y or a and b. You'll be able to just see that 3 root 7 and 2 root 7 are like terms. 3 root 7 plus 2 root 7 is 5 root 7. And then add in that minus root 6. So here we have 2 root 3 plus 4 root 3 is just equal to 6 root 3. Question B. We have 4 root 6 minus 3 root 6 are our like terms. 4 root 6 minus 3 root 6 is just root 6. There's one lot of root 6. 3 root 2 plus 2 root 2 is 5 root 2. Okay, let's simplify these surds. In question A, we have 5 root 2 minus root 8. They're not like terms, so how are we going to simplify them? Well, in class today we've looked at how to simplify root 8. We've rewritten root 8 as root 4 times root 2. Root 4 times root 2 is equal to root 8. And so what is the square root of 4? It's 2. So this becomes 2 root 2. This root 4, the square root of 4 is 2. Now they are like terms. 5 root 2 minus 2 root 2 is 3 root 2. Question B. It seems like we don't have any like terms here either. But let's rewrite this out. 2 root 5. We want to know what's the largest factor of 20 that is a square number. The largest factor of 20 that is a square number is 4. So I'm going to split this off into 3 times root 4 times root 5. Because 4 times 5 is 20. So root 4 times root 5 is root 20. Then I'm going to add my 6 times, what's the largest factor of 45 that is a square number? That's 9. So root 9 times root 5. 9 times 5 is 45, therefore root 9 times root 5 is root 45. Let's simplify this to root 5. Now, what is the square root of 4? The square root of 4 is 2. Therefore, 3 times 2 is 6 times root 5 is 6 root 5. What is the square root of 9? The square root of 9 is 3. So 6 times 3 is 18. So we have 18 root 5 over here in purple. And now we see that they are all like terms. Okay, they're all in terms of root 5. So we have 2 root 5. It's like saying, I'm just going to do this in green, it's like saying 2x minus 6x plus 18x. Okay, it's similar to saying that. But instead of x, we're using root 5. Let me just work this one out. 2x minus 6x is minus 4x. Plus 18x is 14x. Therefore, this answer here is 14 root 5. Okay, 2 minus 6 is minus 4. Minus 4 plus 18 is 14. So we have 14 root 5. Let's have a look at some harder questions. Here we have a fraction minus another fraction. In order to do that, we need to have the same denominator. Okay, so I'm going to cross multiply. So it's going to be over 9 times 5 is 45. 9 times 5 is 45. I'm going to cross multiply this way. 4 root 7 times 5 is 20 root 7. Then cross multiply the other way. 9 times 3 root 7 is 27 root 7. And remember, this is a minus sign, so we need to put a minus sign. 20 root 7 minus 27 root 7 is minus 7 root 7 all over 45. Now, if we can simplify this fraction, okay, if we can simplify that fraction, simplify it. Here we can't, so I'm going to leave that as our answer. Question B. Here we have 11 minus 2 root 13 over 3 plus root 13. Again, they don't have the same denominator. So I'm going to make them all have the same denominator by multiplying everything by 3. I'm going to put everything over 3. I want everything to be over 3. But if I were to do that, I need to multiply the numerator by 3 as well. So I'm going to rewrite this. 3 times 11 is 33 minus 2 root 13. I didn't need to multiply that by anything because it's already over 3. Plus 3 times root 13 is 3 root 13. All of that over 3. Here we have our like terms. Minus 2 root 3 plus 3 root 3 is equal to, minus 2 root 13 plus 3 root 13 is equal to 1 root 13 all over 3. And that's our final answer. Question C, same thing. Okay, last one. Cross multiply, we need the same denominators. 3 times 4, 4 times 3 is 12. That's 12. 3 times 3 root 5 is 9 root 5. Multiply the other way. 4 times root 20. Put our minus sign first, because it says minus. 4 times root 20 is 4 root 20. Now, we don't see any like terms. But this root 20 here, can we split that up? Is there a factor of 20 that is a square number? Yes, there is. That square number is 4. So we've got 9 root 5 minus 4 times. We can split root 20 into root 4 times root 5. 4 times 5 is 20, therefore root 4 times root 5 is root 20. All over 12. What is the square root of 4? The square root of 4 is 2. Therefore, minus 4 times 2 is minus 8. Minus 8 times root 5 is minus 8 root 5. So we've got 9 root 5 minus 8 root 5 all over 12. Okay, we have like terms. 9 root 5 minus 8 root 5 is just root 5 over 12. It's like saying 9x minus 8x is just x, but instead of x, we're using root 5. And that's it for this video.